All right, so the first little bit of this is vocabulary, and this is not on your theorem sheet, but it is in your notes. So if you don't know how to do it, look up into your notes. So a diameter is a chord, but it goes through the center. So we're going to call it by its endpoints, AB. And since it has endpoints and doesn't go on forever, it gets a flat hat. A radius is half of the diameter. So we've got two of those in the picture. You could either pick CB or AC, and it wouldn't matter. So either one of those. The directions just say to use 2 points. So it's just a reminder. A chord is a line segment that touches the circle twice. So we've got two of those. Diameters are considered special chords, so you could put AB, but AG is another one. And to make sure people know that you're talking about the chord, which has end points on the circle, you just give it a flat hat. That means it's a line segment. So you'll notice the difference just in the word. This is a secant line and a tangent line. Lines need to have arrow hats. So a secant is basically like a chord that goes through it, though. I don't think I'm using that terminology correctly, but a line that touches the circle in two different spots. So again, I could name it AG. It just has to have the arrow hat. Or I could name it AE also. The biggest difference is it's got to have that arrow on its hat. Okay, tangents are also lines. Now, our most recent tangents we've talked about were tangent segments. So they had endpoints. This is back at the beginning vocabulary when it did not. So it could be called DB or DE. So there's three different names you could give it. DB, as long as you give it an arrow hat, or you could have looked at D and E, or you could have called it, what did I miss? BE. But the arrow hat is what makes all of those the same thing. Okay. You might want your theorems paper, if you don't remember how to do these, to show your work. So if I put yes, or if I decide the answer is no and I don't show my work, I can't get full credit for ones like these. So there is a theorem that talks about that a tangent will meet a radius at a 90-degree angle. So if that is in fact a tangent, this is going to be a right triangle. And the Pythagorean theorem would work. I had some kids saying, no, because the 35 is not the longest side. Some kids were feeling like this was the 90-degree angle, so just be careful with those rules or theorems. So I think this is tangent line to circle. So a tangent, it's a tangent line to a circle if and only if the line is perpendicular to the radius. So we're checking to see if that is in fact true, and again, that would make this a right triangle. So A squared plus B squared would have to equal C squared. So I would say just, kind of type these into your calculator. 37 squared is 1,369. 35 squared is 1,225. This is 144. So we do have to add those together. So yeah, this is a right triangle, which means yes, ST would be tangent. And again, that's from the very first theorem we talked about, tangent line to a circle. A line is tangent to a circle if and only if the line is perpendicular to the radius. So we were double checking that. Okay, number 7 also is talking about this point of tangency. So this is external tangent congruence. Tangent segments from a common external point are congruent. So if they're congruent, always it's saying, I can set them equal to one another. Congruent means it's the same measure in a different location. So x is going to equal positive or negative 3. Negative 3 doesn't really make sense, so my answer will be 3 here. And again, show your work. All right, so as we move along, I'm just keeping my theorem page in front of me. We've covered tangent line to circle and external tangent congruence, so I'm looking at these next two thinking I might be using them soon. What arc is congruent to arc AB? So congruent central angles theorem In the same or congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. These are congruent because they're vertical angles. So the congruent arc would be CD, and remember to put this curved line above it or you have not named it properly. And that's from that third theorem, congruent central angles theorem. Okay, find the measure of arc R, T, S. And they gave me that third letter to let me know which direction. I have to pass the T before I get to the S. Okay, so I'm looking at my central angle definition. There's not a place in the boxes, but I wrote mine up above. And it says a central angle is an angle that has the vertex in the center of the circle. So this here is a central angle. Looks like Pac-Man now. And it says that the central angle is congruent to the arc measure. So this is also considered 110 degrees. They reflect one another. So how do I find this big, huge arc? Hopefully you can remember that the entire circle is 360 degrees. So if I take away the piece that I do know, the 110, I'm left with the measure of arc R, T, S. Now, the only reason I put that word there, you don't need it. I don't know if you can tell. I had to draw this in with my pen. My computer didn't have that notation on it. So normally you don't have to write the word arc. What number is this? It's kind of cut off. 10? Okay, GF is 9. What's FI? It looks like it's going to be 9, but which property is going to prove that? So perpendicular chord bisector theorem says if a diameter is perpendicular to a chord, which it is, and we know that because they gave us the 90-degree angle mark, then it bisects the chord and the arc. So we didn't have to use the arc rule. We just used the measure of the chord rule, but that's why it's 9. You're going to want to know for sure these rules. Okay, the next one. What is the measure of arc HK? How would we go about doing that? Well, we're using the same theorem, perpendicular chord bisector theorem. If you don't have your theorem page sitting there and you're not reading it and making sure you got notes on there, please get it out and double check. You might be watching me and thinking this is so easy and then go to try to do it yourself and lose your confidence. So again, if a diameter is perpendicular to a chord, which it is, then these segments are congruent and their corresponding arcs are congruent. So I need to find out what X is. I know they're congruent, which means they're the same measure in a different location. Okay, if X equals 7, then these are both going to be 77 degrees. So I got that by plugging a 7 in here. 11 times 7 is 77. This one here is 70 plus 7 is also 77. So let's go back and make sure we're answering the question. What is the measure of arc HK? Now, why didn't I go the long way around? If they don't give you a third letter, go the shortest route possible. So the shortest route possible is that top part. And I'm going to add those 77s together. So it's 154 degrees. Now, unfortunately, I did not do this before making the answer keys on the recording, so I'm hoping I'm doing all these right. Okay, I think that number 12 is one of the most difficult problems on the review. These ones with the right triangle. I wasn't here the day you learned it. We had a substitute. She did an excellent job, but I just wasn't here. So there's lots of things in the picture, and we've got some given. In the diagram, JK is congruent to LM, and they're congruent to 24. Maybe I'll do it in yellow. I hope you can see that on your computer. I know in person that would be really light. And NP, this is already labeled for us. N to P here is 3x, and NQ. It's really light on my board. It's very hard to see. Maybe it's easier on yours. It's the center straight down. That's NQ is 7x minus 12. And ask me to find the radius. The first time I tried to do these problems, all I could think of is the radius that goes, that's already drawn, like NR. So see if you can find NR with your eyes, or NS. I kept feeling like that's what I was looking for. It's just not the case. So what we want to do is draw a right triangle. That's one of the radiuses. NK would be a good radius to find. So how do we go about doing that? Well, if from J to K is 24, if a diameter intersects a chord at a right angle, then it bisects it. So I know these have to be equal, which would make this piece a 12. So again, I'm kind of looking at this right triangle here. This piece is 12. This is my radius. So I've got a 3x as that other side. And then I have this random 7x minus 12. Why did they give that to me? That's the question you need to ask is, what can I use that to find? Well, from the center to, there's another theorem. I'm not really using my paper very well. Equidistant chords theorem. If the same circle or in congruent circles, so we're in the same circle, two chords are congruent, so that's this JK and LM. I highlighted those yellow. They are congruent if and only if they are equidistant from the center. Well, that's helpful. So this must be equivalent to this. So I can do 3. This has nothing to do with the radius right now. I got to find x. I think that's why this problem is so hard, is you've got to take a second to do this part first. So x is going to equal 3. So I'm coming here and looking at this part again. So this will be 3 times 3, which is 9. All right, now I can use the Pythagorean theorem. 9 squared plus 12 squared equals the radius squared. 81 plus 144 equals the radius squared. I'm running out of room. I'll just write it down here. Okay, so to find the radius, I'm going to take the square root of that 225. So 15 equals the radius. So I'm going to erase that because I've gone down into another problem. So if you need to write that down, push pause because I'm going to erase it here in a sec. Okay, inscribed angles. There is nowhere on this paper, the theorem sheet, where it asks you, where it gives you that definition. But I know that I drew a picture of mine. I squoze it in on the back, and I put one on the bottom so that I would make sure that I had it. So an inscribed angle, I said, is an angle whose vertex lies on a circle and whose sides contain chords of the circle. So here's my vertex, and its sides contain, there's one chord it contains, here's another chord it contains. So inscribed angle has to have the vertex on the circle. Now, I don't know if your test will ask for central angle. That's inscribed. A central angle, the vertex lies on the center. So sometimes on the review it'll ask for one, but on the test it will ask for another one. Okay, what is the measure of angle T? That's this angle here. So again, we're going to make sure you're looking at the other side of your paper now. Wait, is that true? Oh, that's not true. Measure of an inscribed angle theorem. The measure of an inscribed angle is half the measure of the intercepted arc. This is the intercepted arc. It's RS, and it's 48. So the measure of this angle is half of that, which is 24 degrees. Okay, this picture looks like bottom right on my theorem paper, an inscribed quadrilateral theorem. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. And remember, to be inscribed, it means that the vertices lie on the circle. So this is saying the opposite angles are supplementary. Please don't set them equal to each other. Supplementary does not mean equal. It means their sum is 180. So please don't say 10x equals 8x. You're going to be in a heap of trouble if you try to do it that way. So it's easy to solve as long as you've got it set up right. Okay, so that didn't answer any of my questions. It didn't say find x. It said find the measure of the angle. So here, 8 times x will be 80 degrees. Don't forget your degree symbol. T is 10 times 10 times 10, which is 100 degrees. Okay, now I've got another variable here, C, and the opposite angle of S is U. So again, they're not equal, they're supplementary. So let's add the 6 to both sides. Meanwhile, I'm going to combine my like terms. Okay, so coming back over, if this is just a C, it's 62 degrees. Don't forget the degree symbol, please. And then 2, and then C is 62, minus 6. 124 minus 6. $118. So 118 degrees. Now you can double check. So if I add these two together, they should be 180. If I add these two together, they should be 180. So you can check your own answer there. Opposite angles are supplementary. If you don't have that highlighted on your formula sheet or your theorems paper, I would highlight that. It's a weird one. Okay, now we're moving into dealing with the arcs. Find the measure of arc. R past the S, back to the T. So this looks like my picture. Let's see if I'm flipping to the back. Oh yeah, I've got to turn it over to the back. Tangent and intersected chord theorem. Here's my tangent. And here's my intersected chord. They're intersecting right here. And it says, if a tangent and a chord intersect at a point on a circle, which I have, they are intersecting at point T, then the measure of each angle is formed is 1/2 the measure of the intercepted arc. So this angle is half the measure of the arc, but I'm going the other way around, so I've got to double that. So I'm doing 98 and I'm doubling it. Find the value of y. Okay, so this is a different picture. Angles inside a circle theorem. If two chords intersect inside a circle, these are two chords, they did intersect inside the circle, then the measure of each angle is 1/2 the sum of the measure of the arcs. 1/2 the measure of the sum of the arcs. So I'm looking here at this arc and this arc. Is this going to help me find? I've got two variables. Oh, I remember we did something like this in our big ideas. So they're giving me this angle is 102, and I need one of these ones. So if you remember, if I take 180 and I subtract the 102, I'm going to get 78 degrees. That's going to be more helpful to use. So y plus 95, half of that will equal the 78. Be careful on those. Those are hard ones, but I am adding them together. So let's get rid of the half first by multiplying both sides by 2. These are going to become a 1. And subtract my 95. What did this ask for? Find the value of y. Did I do it? Yes. So I can always double check this. If I do 95 plus 61, and I divide it by 2, I should get 78 degrees. The tricky on this is the 102 is just a hint, so I could find one of those other angles in there. That one was hard. Okay, find the value of A. So I'm looking at my theorem. This is a circumscribed, nope, it's not. Angle outside a circle theorem. If a tangent and secant, two tangents or two secants, these are two secants, and they're intersecting outside the circle, then the measure of the angle formed is half the difference of the intercepted arcs. So this angle here, J, they're calling it 30, is half the measure of the difference of the intercepted arcs. So the intercepted arcs is A and 44. So I can find the difference. I'm subtracting. Same idea though. I'm going to get rid of this 1/2 first. So I'm going to multiply both sides by 2. Half of 2 is 1, so I can kind of cross that off because distributing a 1 isn't going to change anything in the parentheses. And these are degrees. A is 104 degrees. And if you're not sure you did it right, now that you've got numbers, do 104 minus 44, cut it in half, and you should get that 30. You can check your own answers. Okay, this is a long review. Find the value of x. So this is the stuff we did on Thursday, Friday, Tuesday. Like we've been working on this recently. Hope these are fresh. So exterior piece times the whole piece will equal this exterior piece. I think that's a plus. Times the whole piece, x plus 1 plus x minus 1. Okay, I'm going to do some simplifying here. These ones will cancel each other out. I'm moving my parentheses because I've got to distribute this in. Let's put these together. Got a lot to do here. Okay, distribute. If I just lost you, push pause. Watch that a little bit slower while you combine your own like terms. So I'm distributing. Okay, if you can see that your equation will have an x squared, not when we're talking about circles, this is not circles, this is when we're solving algebraically. So I can see that I've got this x squared and it's not going to cancel out while I solve. If that's the case, put everything on one side because we're going to solve this in a quadratic form. 2x squared minus x minus 15. Ugh. There we go. 2x squared minus x minus 15. Okay. 2x squared minus x minus 15. I'm going to push the graph. Oh no. Oh, I did something weird. 2x squared minus x minus 15. I have no idea what I hit before. Okay, so x cannot be negative because it's a distance. So I'm going to see what my x-intercept is. The positive one is 3. I don't think I can write, can I? No. It's going to be 3. That intercept is 3. So that's going to be my answer. Let's see if I can get out of this. So if you're not sure if that's right, plug it back in. So we've got a 5 here. 3 plus 1 is 4. 3 minus 1 is 2. So this might be easier. 3 times the whole thing would equal 4 times the whole thing. Is that true? Well, yes, then we did it right. We found the right value because now that we've got a lot easier numbers, it still worked out. So I'm going to be erasing this. If you need to write it down or figure it out, go ahead and push pause. Okay, This one is similar theorem. I gotten out of the habit of reading them. So I'm on the back of my paper, and we've got, oh, I just turned it to the front. Segments of chords theorems. If two chords intersect in the interior of a circle, check. Then the product of the lengths of the segments of one chord equal the product of the lengths of the other chord. So the product means to multiply equals the product of the lengths of the other chord. The main difference from this picture is I'm not adding anything together. Like I don't have to add 4 plus 3. So simplify and solve. And you can always go back and find these, like put the 5 in for x and solve it, see if it worked. Is 2 times 4 equal 4 times 3? Yes. Okay, find the value of x. What is this? This looks like angles outside a circle. Circumscribe. This looks like a couple different ones. The first thing it looks like to me is a circumscribed angle. The measure of a circumscribed angle is 180 minus the measure of the central angle. The measure of a circumscribed angle. Oh, what? Oh, this one. This is a circumscribed angle. Is 180 minus the measure of the central angle. Oops, I did something weird there. Okay, so let's do minus 180. I'm sure there's another way to find this, but I'm doing this kind of on the spot. And this is what my brain is coming up with. So this is a central angle, which they did not ask for this. They didn't ask for the central angle. They asked for the inscribed angle. But I know that that's going to make this arc also 150 degrees. And I know that the inscribed angle will be half of that. I feel like it's 170 or 75, but I'm doubting myself. Oh, yeah. Okay, so I hope that's the easiest way to do it. I'm not sure. I don't see a direct correlation between these two. What's 150 minus 30 divided by 2? Nope, I don't see a direct correlation. We've got to find the central angle first. And I used the circumscribed angle theorem. And then I used my knowledge about central angles to find my inscribed angle. Okay, the general equation x minus h squared, y minus k squared equals the radius squared. What does r represent? HK is the center of the circle. R is the radius. Text. Okay, so the equation of this circle, it's kind of hard to see on here. The center, it looks like these are skip counting by 3, 6. All right, sorry, I had my phone ring, so now I don't know what I was doing. Right, the general equation. So here's what I'm doing, and I need to plug in the h and the k, so I need to find the center of the circle, and I need to plug in r. So really, you can start out with quite a bit of this equation. Right, like that's always the same. Okay, the center though. Oh, this is skip counting by 3s. 3, 6, 9, 12. So strange. So if I go back 1 space, that's -3. And if I go up 1 space, that's a +3. So that's my center. And my radius is 3, 6. They had to make it a little bit harder. You guys are high schoolers. So the hard part of that was just the skip counting, in my opinion. Okay, so x minus negative 3, I'm just going to change it to a plus, and y minus the 3 equals 6 squared. 6 squared is 36. Make sure that yours has a 36 here. Make sure yours has a plus there. So same idea. The stuff is always the same. It doesn't, the only thing that changes is the radius and the center. So x minus negative 2, I'm going to just change it to a plus right now. Y minus, and then the 4. And 5 squared is going to be 25. This is what your equation should look like. If you have a 5 squared, change it to 25. You'll miss partial credit there. Write an equation of a circle. I need to find the radius. So I can do this part. But circumference is 2 pi r. So I'm going to divide both sides by this 2 pi so that when this cancels out, my pi's cancel out. My radius is 4, and 4 squared gives me a 16. Oh, I can't believe we have to do this one. Okay, step number 1, get the constant on the other side and organize this part. Organize the left, get the constant on the right. Done. Step number 2, complete the square 2 times. So my thought bubble, I'm doing b over 2 squared. What's half of negative 8? It's negative 4. What's negative 4 squared? 16. I can't just randomly add 16 to one side. I have to keep the equation balanced. What's half of 6? 3. What's 3 squared? 9. I can't randomly add 9. I have to add it to both sides. Step number 3, simplify the right. Factor the left. I know a shortcut for factoring, but you may not. So I'm going to use the X Games. That's the one that you're most familiar with. And keep in mind, we're trying to make this a really great circle equation instead of a horrible circle equation. So it's got to end up looking like this. What are 2 things that multiply to be 16 and add to be negative 8? And they better be the same or you've messed something up because we've got to be able to square that. All right, let's do the one with the y. What are 2 things that multiply to be 9 and add to be 6? And they should be the same thing. All right, so what was this asking us? Find the center. Please be careful with this. The h is positive 4. The k is negative 3. And my radius is 4. There's a little bit of decoding there. So if I'm graphing it 1, 2, 3, 4, negative 3, I'm going to be off my graph here. 4, 4. Well, you're just going to have to use your imagination.